So, in order to solve this equation, we're going to start by taking the 4 and plugging it in for f of x. And then whenever we're solving a polynomial, we want to make it equal 0. So we're going to subtract 4. Okay, at this point we're going to put the equation into our calculator in y equals and see what it looks like. Okay, on the graph we're going to look for where the graph crosses the x-axis, and it is at x equals 2. Okay, so 2 will be the number that we will do synthetic division with. We'll bring down the 1 for the x to the third, the negative 5 for the x squared, the 1 for the x, and 10. Bring down the 1, and we start. Multiply, get 2, add, get negative 3, multiply, get negative 6, add, get negative 5, multiply, get negative 10, and there's the remainder of 0. So if we put the x's back in, remember we divided, so we lost an x, so we have 1x squared minus 3x minus 5. And that still equals 0 because it equaled 0 way up there. And we have to solve what's left with either factoring or the quadratic formula. And I think that we'll need the quadratic formula. No two numbers multiply to negative 5 and add to negative 3. So the quadratic formula it is x equals 3 plus or minus the square root of 3 squared, so 9 minus 4 times 1 times negative 5, all over 2 times 1, so 2. So 3 plus or minus the square root of 29 when we type the inside part of the square root in the calculator, divided by 2. So we'll type that in our calculator. 3 plus the square root of 29. Remember to hit enter, then divide by 2. So 4.193, or 3 minus the square root of 29, hit equals, and divide by 2. Negative 1.193. And so we have those two answers right here. And we have the x equals 2 from the calculator, and we proved it by getting 0 for the remainder. And so those are the 3 solutions to our equation. Okay, and now we're going to talk about what if it's an x to the 4th. How does that change things? Again, plug in the y value. Make it equal 0. And graph it in your graphing calculator. Okay, so when we look at the graph on our calculator, it looks like the x-intercepts are negative 1 and positive 3. So pick either one of those to begin the synthetic division. I'll do negative 1. So we bring down the 1 for the x to the 4th. We don't have any x to the 3rd, so we're going to put 0 instead of that. Then negative 5 for the x squared, negative 10 for the x's. Oops, that's messy. Negative 10 for the x's, and then negative 6. Bring down the 1, multiply, get negative 1, add, get negative 1, multiply, get 1, add, get negative 4, multiply, get 4, add, get negative 6, multiply, get 6, add to get 0. Now this is still too big. If we put the x's back in, we'd still be at x to the third. So we actually need to divide a second time by the second x-intercept that we see, which was 3. So bring down the 1, multiply, get 3, add, get 2, multiply, get 6, add, get 2, multiply, get 6, and there's the other remainder 0. So now we can put the x's back in. We've divided twice, so we are down to an x squared plus 2x plus 2, and we still equal 0 because we equaled 0 at the beginning. Again, nothing multiplies to 2 and adds to 2, so we're going to go to the quadratic formula to get the last two answers. So x equals -2 plus or minus the square root of 2 squared. So 4 minus 4 times 1 times 2 over 2. 2 times 1. So that'll be the square root of, a negative number. So -2 plus or minus the square root of -4 over 2. So we have an imaginary set of answers here, -2 plus or minus I square root 4 divided by 2. We can leave that there because they're imaginary. And our real answers are x equals -1 and x equals +3, which we found and proved on the graphing calculator. So there are 4 answers, 2 real, 2 imaginary for that problem.